In this video we have another problem dealing with applications of Extrema. So here's the problem. Find the coordinates of the point and the curve y equal the square root of x closest to the point 40. So this is really a minimum problem. If you want to pause the video and take a shot at this, go ahead, then I'll be right back. We don't really need a graph for this, but I'll go ahead and put it in there. We have y equal to the square root of x. So that's this part of the parabola that opens to the right. And we got the point 40 somewhere over here. And then we have a point on the curve. We'll label it xy. So we want to find minimum distance from any particular point on this curve to that point 40. So this is really a distance formula application. So I'm going to go ahead and label this distance function as d of x is equal to the square root. Find the distance formula, it's x minus 4 under the radical. Difference in the x coordinates squared plus the difference in the y coordinates squared, so it'll be y minus 0 quantity squared. And then we go through the simplification of this. It'll be the square root then. Square this out, x squared minus 8x plus 16. And then the second term here will be y minus 0 squared. It's going to be y squared. If you look at this, y squared is radical x squared, which will just give me x. So now I have the distance function in terms of x, which is what I want here. So this then is going to give me the square root x squared, and I have minus 8x plus 1x, that's minus 7x plus 16. And this is now your distance function here. So we want to find the critical numbers of this function here. Now I could go ahead and square both sides and find the critical numbers for the square of this, and it'll still work out. But I'll just go ahead and leave it this way. And just take the derivative right here. It's not really that bad. So the derivative here then, this is a radical, so this is to the 1/2 power, so this will be 1/2 out here. And I'll have this x squared. We have minus 7x plus 16. And then we subtract 1 from the power here, which is 1/2, will give me minus 1/2 here. And got to use a chain rule here, so I take the square of the derivative of what's inside here, this x squared minus 7x, so this will give me a 2x minus 7. And to solve the problem, we need to find the critical values or the critical numbers of this function. So again, critical numbers are numbers in the domain of the function for which the derivative is either 0 or undefined. So this is in the numerator, this 2x minus 7 is in the numerator of the derivative. So we know that, let me erase some of this stuff up here. One critical number, numerator again is 2x minus 7, so if you set that equal to 0, solve for x, you're going to get x equal to 7 over 2, or 7/2. That's a critical number. Now this part of it right here, because it has a negative exponent, that's the denominator. So do we have any values for which the denominator is 0? That would be the derivative would be undefined at those values. But if you look at this quadratic, if you set this equal to 0 to try to solve it, this has no real solutions. So you use the quadratic formula to try to solve this. Use the discriminant of it, the b squared minus 4ac of the formula. That's the expression under the radical when you use the quadratic formula, this would come out negative. So this would tell you that there's no real solution. So the only values for which the derivative is 0 is 7/2. There are no values for which it's undefined. So this is the only critical number. So all you have to do then, using the first derivative test, there is a second derivative test. You can do most of these with the first derivative test. And all you have to do with the first derivative test, as we saw in the earlier videos, is you look at the sign of the derivative to the left and to the right of the critical number. So if I pick a number, this is 7/2, it's 3.5. So let's pick a number, say 4, and put it into the derivative. So if I put a 4 right here, the x is 2 times 4 is 8 minus 7. This is positive. If I put it in here, x squared minus 7x plus 16, that's going to be positive. So to the right of 7/2, the derivative is positive. To the left, pick a number less than 7/2, say 3. Put a 3 here for x and the 2x minus 7. This will give me a negative, but this expression over here will give me a positive. So this is going to be negative. So this tells me then that because I have a negative to positive for the derivative, the curve at that particular value is falling, derivative negative, and then it rises. So it has a minimum at 7/2. So the relative minimum in this case is at 7/2, and it's asking for the point closest to 40. So the first coordinate would be 7/2, and then I put 7/2 into the function y equal this one, the original function, y equal square root of x, and the second coordinate would be, the y value would be the square root of 7/2. Or if you want to rationalize this, this would be 7/2. Simplify the y coordinate, multiplying by 2 and 2 here will give me the square root of 14/2. So that's your solution for this one. The coordinates of the point closest to the point 40, where the point is on this particular curve, is 7/2 and the square root of 14/2. Thanks for watching. We'll see you next time.